Yusoff AF180110.
So, my name is Nurshami Binti Hamza, AF180199.
Hi, my name is Yusoff.
Rock mass classification. Rock mass classification is the process of setting a rock mass into groups on characterized relationships and relegating a sole description to it on the basis of similar characteristics. While for rock mass strength, RMS classification is an alteration of the RMR system as it involves the initial 5 parameters of RMR basic. In the background of our project, there are 4 principles in rock mass strength, which are mathematical modeling, rock mass classification, large-scale testing, and back analysis of failures. In rock mass classification, plan can be utilized to develop the composition and characteristics of a rock mass, to give best estimates of support requirements, and to give assessments of the strength and deformation properties of the rock mass. The significant parameters in rock mass strength RMS. There are 5 of it, which is condition of discontinuity, joint or discontinuity spacing, groundwater condition, uniaxial compressive strength UCS, physical scale, and rock quality designation RQD. In literature review, according to Bineski 1993, rock mass classification is the process of setting a rock mass into groups or classes on characterized relationships and relegating a sole description to it on the basis of similar properties, such that the behavior of the rock mass can be anticipated. He also stated that the rock mass classification systems were planned to act as designing plan help and were not expected to substitute field perceptions, analytical considerations, measurements, and engineering judgment. However, it should be utilized related to other design schemes to devise a general overall rationale compatible with the design objectives and site geology. The objective of rock mass characterization and classification. There are 5 of it, which is the first one is to partition a specific rock mass formation into various of rock mass classes of fluctuating quality to provide a basis for understanding the characteristic of each rock mass class. To identify the most significant parameters influencing the behavior of a rock mass. To derive quantitative data for engineering design. Next is the advantages and the disadvantages of rock mass classification. As we can see from the slide, there are few of the advantages and the disadvantages provided in the slide.
These are the equipment that needed to conduct rock mass strength assessment: measuring tape, fracture gauge, Smith rebound hammer, and torchlight. There are 7 steps to classifying and implementing the RMS system. Step 1. Outcrop preparation. Choose an outcrop on the tunnel wall with distance of 5 meters as shown in the figure, using measuring tape to set up the distance. Step 2. Uniaxial compressive strength. The uniaxial compressive strength is the maximum axial compressive stress that a sample can withstand. Smith rebound hammer is used to determine the UCS of rock mass. This figure shows the graph of uniaxial compressive strength against the value on Smith rebound hammer. There are 7 different grades, R0 to R6, which is extremely weak to extremely strong. Step 3. Rock quality designation. Rock quality designation is a rough measure of the degree of jointing or fracture in a rock mass, measured as a percentage of the drill core in length of 10 cm or more. RQD can be determined by using equation 1. If there is no core present but discontinuity traces are visible in surface exposure, the RQD may be predicted from the number of discontinuity per unit volume as equation 2, where JV is known as the total number of joints per meter cube, and RQD equals 100 for JV less than 4.5. High quality rock has an RQD of more than 75%, low quality of rock has less than 50%. Step 4. Joint or discontinuity spacing. One of the major geological features in a rock mass to classify strength is through joint or discontinuity spacing. Discontinuity spacing is one of the important parameters in describing the strength of a complete rock mass. Step 5. Condition of discontinuities. Discontinuities condition can be determined based on persistence, which can be measured by measuring tape, aperture, joint opening, by using ruler or fracture gauge, roughness, rock plumb on joint surface, infilling, observe the material condition inside joint aperture, weathering, observe the iron stain along joint wall, friability, color, and texture. Step 6. Groundwater condition. It is account for groundwater inflow in excavation stability. Groundwater for completely dry condition can be obtained from table below rock mass rating system. Step 7. Physical skill. If the sample size increases, the skill effect in joint which the peak shear strength decreases. The mechanical behavior of the rock mass is depend on the strength of block created by random pattern of discontinuity and their strength. The number of block increases, the tilt angle also increases. In a small scale of the rock was intact compared to a very joint rock mass in their largest chosen scale, the behavior of a blocky rock mass at the scale of 10 meter is vastly different from the blocky rock mass at the scale of 500 meter. The effect of scale on rock mass strength can be easily seen by figure below.
Rock mass properties is governed by the properties of intact rock and the properties of discontinuities in the rock. Intact rock can be referred to the fracture blocks between the discontinuities in typical rock mass. Discontinuities in rock means any separation in rock mass by having zero or low tensile strength. Therefore, the properties of rock mass can be determined by the parameters of rock joints and rock material. The existence of rock joints, material parameters and boundary conditions play important role. In 1946, rock class and rock load factor classification by Terzaghi for steel arch supported tunnels Terzaghi. The rock mass is classified into 9 classes, from hard rock to blocky rock and to squeezing rock. For obtaining the support pressure from the rock load factor, Terzaghi suggested the equation P equal to H P gamma H. Singh and Gold 1999 give the following comments to the rock load factor classification. First, it provides reasonable support pressure estimates for small tunnels with diameter up to 6 meters. It gives overestimates for large tunnels with diameter above 6 meters. Third, the estimated support pressure has a wide range for squeezing and swelling rock conditions for a meaningful application. Mass index is proposed as a file describing rock mass strength as a development material. It is determined by the accompanying equation as stated. Jp is indeed a decrease factor representing the impacts of joining on the strength of rock mass. Jp equal to 1 for an intact rock, Jp equal to 0 for a crushed rock mass. Classification by active span and stand-up time. Active span is indeed the largest dimension of the unsupported tunnel section. Stand-up time is the length of time which an excavated opening with a given active span can stand without any means of reinforcement. Rock classes from A to G are appointed by the stand-up time for a given active span. Class A represented very good rock classes and Class G represented very poor of rock classes.